Welcome to Week 2 of Educational Statistics. Today, we will explore the types of data and the scales of measurement, the foundation for all statistical work. Understanding these concepts will help you choose the right methods when analyzing data. Data in education comes from many sources. It could be your exam scores, attendance records, answers to a survey, or even classroom observations. But not all data is the same. The type of data you have will determine how you can process and interpret it. In statistics, we first divide data into two main categories, qualitative and quantitative. Qualitative data describes categories or qualities. It answers questions like, what is your favorite subject? Or, which type of school do you attend? These answers are not numbers, but they can be grouped or labeled. Quantitative data, on the other hand, uses numbers. It measures or counts something. Examples include the number of students in a class or the score you achieved on a test. This type of data can be used for mathematical calculations. Quantitative data can be further divided into discrete and continuous types. Discrete data comes in separate, countable values, such as the number of lessons you attend each week. Continuous data can take any value within a range, like your exact height or the time it takes to complete a quiz. Now, let's move to measurement scales, a key idea in statistics. There are four main scales: nominal, ordinal, interval, and ratio. Each scale has its own properties and will determine what statistical analysis is possible. Nominal scale data simply names or categorizes things without any order. For example, public school, private school, and international school are categories, but none is ranked above the other. Ordinal scale data has an order, but the differences between ranks are not equal. An example is ranking class participation as very active, active, or less active. You know the order, but not the exact gap between them. Interval scale data has ordered categories with equal distances between values, but no true zero. For example, temperature in Celsius. The difference between 20 degrees and 30 degrees is the same as between 30 degrees and 40 degrees, but zero does not mean no temperature. Ratio scale data is like interval data, but it has a true zero. This allows statements like, twice as much, or half as much. Examples include weight, height, and test scores out of 100. Let's bring this into an educational context. If you collect students' preferred learning styles, visual, auditory, or kinesthetic, you have nominal data. If you rank students based on participation, that is ordinal data. If you measure test scores, that is ratio data. And if you record the time homework is submitted during the day, those times are interval data if you do not count from a true zero. In Indonesia, teachers often collect mixed data in the same survey. For example, a questionnaire might have nominal data for gender, ordinal data for satisfaction, and ratio data for exam scores. Recognizing these differences is important because each type requires different analysis methods. If you treat ordinal data as ratio data, you might make incorrect conclusions. Similarly, if you try to calculate the average of nominal categories like favorite subject, it will not make sense. Choosing the correct statistical approach starts with knowing your data type and scale. The benefits of understanding data types are clear. It leads to more accurate analysis, better graphs, and stronger conclusions. This means you can use data to plan lessons more effectively, identify learning problems, and create evidence-based solutions. Before we end today's lesson, I want you to reflect. Think of one research question in education. What kind of data would you collect? Would it be qualitative or quantitative? Which scale would it belong to? Next week, we will explore descriptive statistics, starting with measures of central tendency, mean, median, and mode. These tools will help us summarize data clearly and effectively. Thank you for joining Week 2 of Educational Statistics. Keep thinking critically about data, and remember, the first step in good statistics is knowing exactly what kind of data you have.